So, looking at this Systems with Circle worksheet, the first three are graphing problems. So in order to graph these, you have to set them, you have to have y equals. Now, if I have two circles, how many times can two circles intersect? Once, or twice, or infinite. Good. So if I have two circles, that would be no solution, because they don't touch. They could touch once, they could touch twice, or they, well, if they were the same size, they could touch an infinite number of times. Okay. So in order to graph these, you have to have y equals. So let's solve for y. I'm going to take this x squared and move it to the other side. So I get 25 minus x squared. Then what? Square root it. And a really common misconception is, oh, square root of 25 is 5, and square root of x is x. X squared is x. And don't forget the plus or minus. How come this is not true? So what you're saying is, if this is true, if those are equal, then I should be able to do that, and they'll equal each other. But when I multiply those, I'm going to get a middle term. So this 25 minus x squared is actually a difference of squares, and it does factor, but it factors into 5 minus x and 5 plus x. So they're not actually the same value. So you cannot simplify that any further. So that's the first equation. The second equation, we're going to subtract the x minus 3 squared. So I get y equals 4 minus x minus 3 squared. Then I take the square root. Everybody okay with that? So let's plug these into our calculator. So square root of 25 minus x squared. And if you have the old system on your calculator, it will put one parenthesis there, and you need to put another one at the end. Mine, everything is underneath the square root. And so on the other one, you'll also have to put parentheses around it. So well, that's right. So plug those in, and you should get this. What's that? Yeah, you do one that's positive and one that's negative. Zoom 6. Yes. Oh, hold on, I messed up one of mine. Oh, I see why it didn't work. Okay, so there, that's what it should look like. Now, these don't look like circles, they look like ellipses. If you want to fix that, you could push zoom square, and it will crunch the x-axis down until they're actually circular. You only graph the positive versions, so you need to graph the negative versions also. So you did the positive of one and the negative of the other. You need to do a positive of both and a negative of both. Yeah, there are 4 equations, because circles are not functions, and your calculator will only graph functions. You can just one of your problems is wrong. Go back to the graph window. It's 4 minus x minus 3 squared. Yeah. Okay, so to find the intersection, and this one only has one, You have to be careful on which two lines you pick. So second calc, intersect, and mine is y1 and not y2. Not y4, but y3. So I picked the top half of both circles, and I'm going to go over here for a guess. I just hit enter on both, on the top two equations. Second calc, and then go to intersect. So it's saying that the intersection is 5 comma 2.6 e to the negative 6. Whoa. What does that mean? Nope. It's very, very, very small. That negative 6 says take the decimal to the left 6 places. So if I move this decimal 2.6 to the left, that's 0.00000026, which is really small, which is the calculator trying to be smarter than it actually is. So anytime you see e to the negative, it's just 0. That's fine. Yeah. Depending on where you picked the two lines and where you picked for the intersection, it might actually say 5, 0. But where I picked it, it didn't work, so. Okay, so that wasn't too bad. Yes. So you need to draw those two in. Just be close. That's good enough for me. All right, for number B, we have a linear equation and a circular equation. So we need to solve the circular equation for y. So I'm going to take 16. What do I move first? The whole x plus 3 squared. So 16 minus parenthesis x plus 3 squared. What number? The top one is a line. So we're finding the intersection of a line in a circle. But it's already in y equals form. So we're good. Okay. Now once I get rid of that, what do? Take the square root. So plus or minus the square root. And then we'll put a 2 in front. So we're going to graph a linear equation, negative 3x plus 1. I'm going to turn this graph off. And then 2 plus, let's insert 16. Is that a plus 3? I can't see. Yeah. Yeah, there will be 3 equations. So you should get a graph that looks like that. If you have trouble, let me know. So we need to do second calc, go to intersect. So I'll find the intersection of the line and the top curve. So I go over to guess. So negative 1.579 and 5.739. Okay. And then same thing for the other half. And I get negative 3.9 and negative 0.139. You just do second calc, intersect again, and just pick 2 new lines. So up and down will jump between lines. Left and right will move along one of the lines. So you just have to be careful when you pick them that you pick the correct ones. Okay. Last one. So we have a quadratic and a circle. So I need to solve the circle for y. So 4 What do I move first? The whole x, so minus parenthesis x minus 3 squared. What's the next step? Take the square root. So there's a plus or minus, and then add the 2. So it's pretty similar to the last one we just did. So quadratic is x squared minus 6x plus 5. Well, I already had it. So you end up with a parabola. Oops, hold on, I messed something up. My parabola's in the wrong place. Oh, I forgot an x. So there's my parabola, and there's my circle. How many intersection points are there? None. No solution. Yep. Draw the graph, write no solutions. Okay, that's half the worksheet. For the other half, we're going to solve the systems algebraically. So we're not allowed to graph these. My recommendation is, if you can use elimination, use it. Elimination makes the problems a lot easier. But elimination can only be used a few times. I mean, not very often. Usually you have to use substitution. Substitution will work almost all the time. It's just a lot longer in some cases. So in part D, is it possible to rearrange or do something to the bottom equation so that a variable will eliminate? If I move the x squared to the left side, then I have x squared on top and negative x squared on bottom, and the x squareds cancel. So I'm going to move this x squared over here, and I get negative x squared plus y equals negative 5. Okay? So now when I add these two equations together, oops. Right, I moved the x squared from the right to the left, so I subtracted it. So now I add vertically. Negative x squared and positive x squared cancel. That's what I wanted. What is y plus y squared? Y squared plus y? Y squared plus y equals negative, or just 20, just regular 20. Okay. Now what do I want to do? Well, if it was y, if it just had a single y, I would solve for y. But it's a y squared. So how do you solve if there's a y squared? Come on, we've been doing this for a long time. Nope, square root won't work. A square root would work if there wasn't a regular y in there. But I have a y squared and a y. No, if you square rooted it, y squared plus y does not square root at all. Because it's not a perfect square. Remember how we did 25 minus x squared? Tried to square root it, didn't work. So this is just a quadratic. So we set it equal to 0 and we find the roots. So I'm going to move this 20 over. Y squared plus y minus 20 equals 0. Whenever you're looking at a quadratic equation, you just find the roots. Hopefully it factors. Does this one factor? Are there factors of negative 20 that add to be 1? Yes. 5 and negative 4. So y minus 4 and y plus 5. So my y values are what are my roots? Negative 5 and 4. So how many intersections does this have? Not necessarily. It has at least 2, but it could have more than 2. It could have as many as 4. So, well, I know the y values. How do I find the x values? What's that? One of them will be. How do we find those? Plug the y's in. Do we have a preference on equations? The bottom one is a lot easier. So let's plug in -5 for the y right here. So -5 equals x squared minus 5. Oh, that's easy. The only thing that makes that true is 0. So one of my points is 0, -5. That's one of the intersection points. Now we plug in -4. So -4 equals, oh, sorry, regular 4. 4 equals x squared minus 5. How do I solve for x? Add the 5, and I get 9 equals x squared. Now what? Square root, and I get plus or minus 3. So how many intersection points are there? 3 of them. So we have 3 comma 4, -3 comma 4, and 0 comma -5. So if you look at the equation of a parabola and a circle, you could have as many as 4 intersections. So the one we're looking at is this, that has 3 intersections, 1 at the bottom and then 2 at the top. You could also have just 2 intersections. You could even have just 1 or none. So we're looking at 3 intersections there. Okay, letter E. Can we eliminate? Well, in the top I have a y and an x. In bottom I have an x squared and a y squared. So there's no way to eliminate. There's no way to line the variables up so they'll all cancel. So we have to do substitution. So we'll take this and we'll plug it in here. So that gives me x minus 1 squared plus x minus 5 minus 4 is x minus 9 squared equals 49. Now I have gotten rid of all of the y values, so now I just solve for x. Well, hopefully you're good at doing this. How does that distribute? X squared minus 1x minus 1x. So it's minus 2x plus 1. Does anybody not know how we did that? Hopefully we're good enough at that that we don't have to do it the long way. Right, so if you don't understand that, just do this. But because they're exactly the same, the two factors are the same, it will always be first one squared, first times second times 2, and then second one squared. So x squared, and then you take the 2 together and double them, and then the last one squared. So for the next one, how's that going to multiply out? X squared minus 18x plus 81, and it equals 49, but I don't want it to equal 49. I want it to equal 0. So I'm going to bring that 49 to the left using subtraction. Okay. Now we simplify. X squared and x squared make 2x squared. How many x's will I end up with? Minus 20x. What is my constant going to be? 1 plus 81 is 82 minus 49 minus or plus 33. Now, we need to factor this to find the roots. But if it doesn't factor, then we're going to waste our time. And it could be irrational, it could be imaginary, we don't know. So we could also complete the square, but in order to complete the square, that x squared has to be a 1x squared. So we'd have to divide by 2, which is a mess. So I recommend the quadratic formula. Okay, help me out with the quadratic formula. Negative b, so 20 plus or minus the square root. B squared is 20 times 20 is 400. And then minus 4 times a, which is 2, times c, which is 33. 4 times 2 is 8. 8 times 33 is 240 plus 24, 264. So minus 264. Over 2. Does everybody understand that? 2a, thank you. Now does it make sense? Okay, 400 minus 264 is 136. So 20 plus or minus the square root of 136 over 4. Now, let's stop for a second. What if this 136 was negative? That means that the quadratic has imaginary roots. If the substituted quadratic has imaginary roots, what does that tell us about the original circle and line? No intersection. So let me spell that out for you. So if this quadratic misses the x-axis, that means that these two equations miss each other. Okay? So if you're solving and you get imaginary roots, that tells you to go back to the original problem and say no solution. Because that if the original two graphs do not intersect, then the quadratic you create using substitution or elimination will have no solution. We'll have no real solution. Okay, but it doesn't. So it has an answer. Well, I could probably simplify the square root of 136, but do I want the square root answer or do I want the decimal answer? The decimal answer, so let's not even bother simplifying this. Let's just plug it in our calculator and figure out what the decimal is. So 20 plus the square root of 136. Should I push divide 2 here? Or divide 4? Let's hit enter and then divide 4, right. It won't work the other way. So we get, are these x's or y's? These are x's. So x equals 7.91. And then 20 minus the square root of 136. Divide that by 4. And the other x value is 2.08. So how many intersections does this have? Exactly 2. How do I know that? The last time I had two y values and I said I didn't know how many intersections there are. Well, it's because this is a line in a circle. How many times can a line in a circle intersect? As many as 2. Well, I have 2 x's, so I'll have 2 y's. So none of these x's are duplicates. Okay, so do you have a preference on equations to plug these back into? The linear one is a lot easier. So we just subtract 5. Y equals 2.91. And subtract 5 from this. Y equals negative 2.92. Those are my two intersection points. Okay. Last one. 2.08 minus 5. Yeah, so how many times can f intersect? We have a parabola and a circle. I could have 4 answers, or 3, or 2, or 1, or none. Okay? So can I use elimination? Yes, I can. What do I need to do in order to eliminate? Move the x squared so it's negative on the other side. So negative x squared plus y equals negative 45. When I add those, the x squareds cancel, and I'm left with y squared plus y, and it's a 9 on the right side, but I don't want it to equal 9, I want it to equal 0, so I subtract 9, or 19. Sorry, 19. So negative 19 equals 0. Does that factor? Are there factors of negative 19 that add to be 1? No. So we have to use either complete the square or quadratic formula. Okay, so negative 1 plus or minus the square root of 1 times 1 is 1. Negative 4 times 1 times negative 19 is positive 76. So plus 76 over 2. Got that? Okay. So, again, I don't want the simplified version. I just want the decimal. So I'll just type in negative 1 plus the square root of 77 and divide that by 2. 3.887 and negative 1 minus the square root of 77 divided by 2, negative 4.887. So how many answers are there? At least 2. There could still be 3 or 4 depending on what we get when we plug them back in. So are these x values or y values? These are y values. So I need to plug them in for y to figure out what my x's are. Okay. So do we have a preference on equations to plug them back into? You want to use the top equation or the bottom equation? The bottom one's probably a little bit easier. So 3.887 equals x squared minus 45. So how do I solve that? How am I going to solve that equation for x? Add the 45. 3.887 plus 45. And then I'm going to raise that to the 0.5, which is the same as square root. And I'm willing to bet if we would have written out all those decimals, the answer would have been 7, exactly. So I add 45, and I get 48.887 equals x squared. And I square root, and my answer is plus or minus 7. So that's 2 answers. 7 comma 3.887. Well, how many decimals did you use? You did 3.887? Oh, yeah, that's this one. So you just did the other one. So, and then the other one is negative 7 comma 3.887. Does everybody understand why there are 2 answers there? When we did that x squared, we got a plus or minus on the x. So those x's, the y values were duplicated. So now we plug in negative 4.887 plus 45. And what do we do to that number? Are we lost? Am I going too fast? Okay, let me write. Okay, so negative 4.887 equals x squared plus, no, minus 45. So I add 45, and I get 40.113 equals x squared. Now I take the square root, and I get plus or minus. So I'm lazy. I don't like to push the square root button and then retype it in. So I just raise it to the 0.5, which is the same as taking the square root. And I'm willing to bet if we were to write all those decimals down, it would actually be 6.3 repeating. That's my guess. So how many answers are there to this problem? Well, this is a plus or minus. And I already have 2 answers. So those are 2 more. So 6.3 comma negative 4.887. And then negative 6.3 comma negative 4.887. Okay, so you have 6 problems to do, and just so you know, if you look at them, I would like you to do problems 1, 2, 3, 4, G, and H. Don't it? Lee Moss is lighting some stuff. Yeah. Notice on the back, on the answer sheet, there is an extra credit problem. If you solve that, you can get 15 points. Show your work, and don't hand those in together. If you do the extra credit problem, hand it straight to me. Also, pick up a practice test. I highly recommend you start it tonight. Your test will be on Friday.